Hello everyone, I am Disha Bharadwaj pursuing computer science engineering from Sri Venkateshwara College of Engineering, and today I'm going to talk about the topic corrosion. So let's get started. Corrosion is the gradual degradation of a material due to chemical reaction. It can have devastating effects on infrastructure and equipment. Understanding its causes and prevention strategies is crucial for various industries. Corrosion is the deterioration of a material as a result of its interaction with the environment. It often involves the formation of oxides and sulfides on the material's surface. It is the gradual decomposition of materials, usually metals, as a result of chemical or electrochemical reactions with the surroundings. Causes of corrosion. Corrosion can be caused by factors such as moisture, oxygen, and electrochemical reactions. Other contributors include acids, salts, and temperature variations. Moisture. When metals collect moisture, an electrochemical reaction causes the steel to corrode. The corrosion process is often accelerated by dissolved salts or impurities in the water. Oxygen. Oxygen reacts with metal atoms, forming metal oxides, otherwise known as rust. Rust is just one type of corrosion, but it's one of the biggest types to affect steel. Unless the steel is kept in an oxygen-free environment, it will slowly rust over time. Chemicals. Acidic substances can corrode metals by attacking their surface. Industrial processes, pollution, and even natural sources like acid rain can introduce acids to the environment, increasing the risk of corrosion. Industrial companies or those that work in construction or similar sectors are at a higher risk. Weather conditions. Metals on exposure to environmental elements like water, wind, and moisture oxidize the metal surface and corrode it. For example, formation of an oxide layer on any metal surface like Fe, Al, etc., forming iron 3 oxide, aluminum oxide, etc. Harmful gases and chemicals. Corrosive substances like NH3, Cl2, sulfur oxide, hydrogen oxides, acids, bases, etc. also promote corrosion of certain electrical equipment. For example, oxidation of copper wires. Biological substances. Dirt and bacteria also cause corrosion in metals. For example, inland water pipes, waste pipes, etc. Effects of corrosion. Corrosion can lead to structural failure, financial losses, and environmental damage. It can compromise the safety and reliability of infrastructure and equipment. Types of corrosion. Corrosion can manifest in various forms, including uniform corrosion, pitting corrosion, and galvanic corrosion. Each type presents unique challenges for prevention and mitigation. Uniform corrosion. Uniform corrosion occurs evenly across a metal surface, resulting in a consistent loss of material. This type of corrosion is influenced by factors such as exposure to corrosive environments and the material's composition. Galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals come into contact in the presence of an electrolyte, such as moisture. The metal that is less resistant to corroding corrodes quicker due to the electrochemical potential difference between the two metals. This process is similar to a battery generating electrical current. Pitting corrosion. Pitting corrosion is characterized by localized corrosion attack creating small pits on the metal surface. It often starts with a small scratch which then becomes an active site for corrosion. Pitting corrosion can be particularly destructive, leading to rapid damage. Factors such as chloride concentration and oxygen availability can significantly influence the severity of pitting corrosion. Crevice corrosion. Crevice corrosion occurs in confined spaces or crevices where the stagnant solution becomes depleted of oxygen and leads to localized corrosion. It commonly affects areas such as gaskets, fasteners, and lap joints. Stress corrosion cracking. Stress corrosion cracking is the result of the combined action of tensile stress and a corrosive environment. It can lead to sudden, catastrophic failure of metals, particularly in industries such as aerospace and nuclear power. High temperature corrosion. High temperature corrosion occurs at elevated temperatures and is influenced by factors such as oxidation, sulfidation, and carburization. It can lead to the degradation of materials in environments such as boilers, gas turbines, and chemical processing plants. Prevention strategies. Preventive measures include coatings, cathodic protection, and material selection. Regular inspection and maintenance are also essential to combat corrosion effectively. Electroplating. Electroplating is a process that uses electric current to cover the thin layer of metal over the top layer of another less expensive metal. It is usually done to provide finishing to the cheaper metals and include certain properties such as anti-corrosion and anti-rust. A common example of electroplating is brass and copper. Galvanization. This process includes a coating of iron with a thin layer of zinc. It is usually done by dipping iron in molten zinc. This zinc layer coating protects the inner part of the iron from corrosion. Painting and greasing. Providing a layer of grease or paint on the metal can prevent the exposure of metal to the external environment and thereby preventing corrosion. Selection of optimum material. Choosing an optimum material can also help in preventing corrosion. Aluminium and stainless steel are highly corrosion resistant. Using corrosion inhibitors. Corrosion inhibitors are the elements that has the ability to diminish the rate of corrosion when added to the corroded environment. Corrosion in infrastructure. Infrastructure such as bridges, pipelines, and buildings are susceptible to corrosion. Proper maintenance and corrosion-resistant materials are critical for longevity. Corrosion in industry. Industries such as oil and gas, marine, and manufacturing are significantly impacted by corrosion. It is a major concern for equipment, pipelines, and storage tanks. Corrosion control methods. Control methods include chemical inhibitors, protective coatings, and design modifications. These methods aim to minimize the impact of corrosion on materials and structures. Regular monitoring and testing of materials and structures are essential for early detection of corrosion. Advanced techniques such as non-destructive testing play a vital role in this process. Environmental impact. Corrosion can have a significant environmental impact through the release of hazardous materials and contamination of soil and water. Proper corrosion management is crucial for environmental protection. Cost of corrosion. The economic cost of corrosion is substantial, including expenses for repair, replacement, and downtime. It is a major concern for industries and infrastructure owners. Ongoing research and innovation in material science and engineering are essential for developing advanced corrosion-resistant materials and technologies. The future of corrosion management lies in innovative technologies, sustainable practices, and collaborative efforts to address this pervasive challenge across industries and infrastructure. So, in conclusion, understanding corrosion is crucial for mitigating its adverse effects. By implementing effective prevention strategies and fostering ongoing research, we can minimize the impact of corrosion on infrastructure and industries. So, thank you for watching the video till the end, and please consider liking it.